All right, let's look at these other two examples that we didn't do yesterday. Let's do, we're going to do letter A and we'll do letter C as well. So in this case, again, one of the ways you can identify a redox reaction, again, is you just kind of look and go, okay, the iodine here has to be a +5, and over here it's a 0. The iodine here is a -1, and again, over here it's a 0. We're going to talk about what type of reaction that is here in just a minute, okay? But that's a good way. Oh, if something's being oxidized, something else is being reduced, that has to be an oxidation-reduction reaction. A lot of times, too, when you see an H plus and an H2O, or even an OH minus and an H2O, that's a good indicator that it's going to be a redox reaction as well. So let's look at this first one here. So IO3 minus, I'm splitting this up into my half reactions, makes I2. And then for the second equation, I minus makes I2. So the first thing we do is we balance the things that aren't oxygen or hydrogen. So I need a 2 right here, and I need a 2 right here. And then I balance the oxygens by using waters. So here on the first one, I have 6 oxygens on the left, so I need 6 waters on the right. The bottom one, I don't need to do anything. The top one, I've got 12 hydrogens in those waters, so I need 12 H pluses over here. And again, on the bottom one, I don't need to do anything. And let's see, overall, I have on the first equation up here, I have a +10 charge. And on the right-hand side, I don't have a charge at all. So I have +10 and 0. So that means I need 10 electrons on this side. And on the bottom one, I've got a -2 over here and a 0 on the other side. So I need 2 electrons on this side. Okay, and now to balance the electrons, I need to take that bottom equation and multiply everything by 5. So that 2 is going to become 10 I minuses. This becomes a 5. And that becomes 10 electrons. Okay, and then overall, we add things up. We cancel things that are the same on opposite sides. So the 10 electrons cancel, 10 electrons cancel. Nothing else does. Again, usually some of the H pluses will cancel and some of the waters will cancel. They probably will here in our next example that we do. Okay, and so now we just put everything together. So we've got, let's kind of do it the same order they have it here. So IO3 minus, we've got 2 IO3 minuses plus 10 I minuses plus 12 H pluses is going to make, now we've got I2 plus 5 more I2s is 6 I2s plus 6 H2Os. And again, if we've done this correctly, we've got, for example, 12 iodines on both sides, we have 12 hydrogens on both sides, and we have 6 oxygens on both sides. So the elements balance, and the total charge on the left-hand side is 0. The total charge on the right-hand side is also 0. If the equation is balanced and the charges are also the same on both sides, that's a really good indicator that you've done this correctly. Okay? And so that is, and again, that obviously goes up here. I just ran out of it. Okay, so that is our balanced equation for that reaction. Okay, our last one, letter C. Notice that this one, instead of an acidic solution, we have what's called a basic solution. You know what a basic solution is by now. Okay, the only other thing you have to do is, right after you add the H pluses to both sides, for every H plus that you've added, add a hydroxide to both sides of the equation. So let me show you what that means. So the first thing I'm going to do is I'm going to split it up. And again, I don't care what's being oxidized, what's being reduced. So Cn minus becoming CNO minus. What's being oxidized here? I don't know, and I don't care. Okay? And then we've got MnO4 minus becoming MnO2. And again, I'm kind of guessing here on what's being oxidized, what's being reduced. But again, nitrogen's -3, so that means here the carbon's +2. And here we've got -2, -3, so that's -5. So here the carbon is +4. So you're going from a +2 to a +4. So it's the carbon that's being oxidized here. And then the manganese is going from a +7 to a +4. So it is being reduced. Okay, and again, it doesn't really matter. Again, we're just going to follow our steps. So we're going to balance things that aren't oxygen or hydrogen. Everything's already balanced. The carbons, the nitrogens in the top equation, plus the manganese in the bottom equation, they're all balanced. Then we balance the oxygens by adding waters. So I need an H2O on this side, and I need 2 H2Os on this side. Okay, now for every hydrogen, I need H pluses. So I need 2 H pluses on this side, and I need 4 H pluses on this side. So here's where the basic part of this comes in. For every H plus that you've added, you have to add that many hydroxides to both sides. Okay, and what that does is, so that means I need to add 2 OH minuses here and 2 OH minuses here. And on the bottom one, I have to add 2 OH minuses, or not 2, sorry, 4 OH minuses. I was still looking at that top one. And 4 OH minuses to this side. Now, again, it's kind of messy now. But basically, so now we just keep going. Okay. One of the things you might notice, though, is H plus OH minus makes water. So really what this is here is that's really 2 more waters. So we've got 1 water on this side, and we've got 2 waters on the right-hand side. So what that does is that cancels out that water, and that leaves us with just 1 water here. Okay, same thing on this one. That is 4 water molecules. Here we have 2. So those 2 are gone, and that leaves us with 2 more over here. Okay, just to kind of clean it up a little bit. So now in terms of charges, let me get rid of these so I don't think that they are charges. So we've got Cn minus and 2 OH minuses, so that's a -3. This side's only a -1, so we do need 2 more electrons on this side. And then on the bottom one, we've got a -1 here, and we've got a -4 here, so that means we need 3 more electrons on this side. Oh, gross. So now, let's keep going. Okay, remember, these waters here are gone. We cancel those out just to kind of get rid of them. Give us a little more room. Okay, so now we need to get those electrons the same, so we need to get to 6. So that means in our top equation, we're going to triple everything. So that becomes 6 OH minuses, 3, 3, 3, and 6. And then the bottom one, we're going to double everything. So that becomes 6, 4, 2, 2, and 8. Okay? And now the electrons are the same. So now we're going to cancel things that are the same on both on opposite sides. So those 6 electrons, the 6 electrons get canceled. Here we have 3 waters. Here we have 4. So those 3 are gone. And 3 of those 4 are gone. So we're left with 1 water. Here we have 6 hydroxides. Those 6 are gone. And that makes 6 of those 8 become 2. Okay, and so now we are, I believe we are done. So I'm just because I'm out of room, I'm just going to put the numbers up here. So I've got a 3. For water, it's just a 1. And MnO4 minus, it's a 2. CnO, it's a 3. 2 MnO2s and 2 OH minuses. So in terms of balancing, 3 carbons, 3 carbons, 3 nitrogens, 3 nitrogens, 2 hydrogens, 2 hydrogens. Let's see, we've got an oxygen plus 8 more oxygens is 9 oxygens. So here's 3, 4, 5, 6, 7, 8, 9. So we have 9 oxygens on both sides, and then 2 manganese on both sides. Okay, so the equation is balanced. And then charge-wise, I count the left side as having a -5, and the right side is also having a -5. Okay, so that equation is now balanced. Now, in terms of the AP exam, usually they're not this hard. Okay, I want to give you the hardest problems possible so that when they're easier, we know that, that there's, they could have asked us a lot more. Okay, a lot of times they make you do these simply because they want you to figure out how many electrons are being transferred. This is going to come up later on in this unit. But like on A, there's 10 electrons that are being transferred. On letter C, there were 6 electrons being transferred. So sometimes they make you do this simply because they want you to figure out how many electrons are being transferred in this redox reaction. Okay, but in general, these questions are not this hard. A lot of times it might just be a half reaction where you just have to balance like maybe this part right here, just one half of that reaction. Or sometimes they're just a lot more simpler. Okay, these are some more complicated ones in terms of balancing redox reactions.